In the vast and interconnected web of life, even the smallest of creatures can embark on extraordinary journeys. Consider the light brown apple moth. It is a seemingly insignificant insect, a small brownish moth that one might easily overlook. Yet, this tiny creature holds a remarkable story of travel and adaptation, a story that intertwines with our own. Its journey across continents reveals much about the delicate balance of ecosystems and the profound impact of human activity. This moth, though small in stature, has become a significant player on the global stage, demonstrating how one species can create ripples that are felt thousands of miles from its original home. Its tail is a powerful reminder that in nature, size is no measure of importance. The apple moth belongs to a grand and ancient lineage of life. To understand its place, we look to its scientific classification, a map of its evolutionary history. It begins in the kingdom Animalia, the great realm of animals. From there, it is placed within the phylum Arthropoda, the group that includes all insects, spiders, and crustaceans, creatures with jointed legs and exoskeletons. It then falls into the class Insecta, the most diverse group of animals on the planet. Within this class, it is part of the order Lepidoptera, the beautiful world of moths and butterflies, known for their scaled wings. Its family is Tortricidae, the leaf roller moths, and finally, its scientific name is Epiphyes postvitana, distinguishing this specific genus and species from all others. This small moth is not just a scientific name, it is a living, breathing organism with a life cycle that drives its survival. The adult moth itself is rather plain, with mottled brown wings that provide excellent camouflage against tree bark and leaf litter. It is the larva, the caterpillar stage, that is most active. These small green caterpillars are voracious eaters, feeding on a wide variety of plants. They have a clever habit of rolling leaves together with silk threads, creating a protective shelter where they can feed safely, hidden from the watchful eyes of predators. This behavior is what gives their family, the leaf roller moths, their name. The story of the apple moth is fascinating because it illustrates a fundamental principle of our modern world. No ecosystem is truly isolated anymore. The same ships and planes that carry people and products across oceans can also carry unseen passengers. The apple moth, in its egg or larval stage, is a perfect stowaway. It can hide on fruits, plants, and in packing materials, traveling silently across vast distances. Its ability to feed on many different types of plants means that wherever it lands, it has a good chance of finding a meal and establishing a new population. This adaptability is the key to its success as a global traveler. The journey of the light brown apple moth begins in one of the world's most unique and isolated landscapes. Its original native home is Australia. Here, for countless generations, it lived as part of a balanced ecosystem. It evolved alongside native Australian plants and was kept in check by natural predators and parasites. In its homeland, the moth was just one small piece of a complex natural puzzle, playing its part without causing widespread disruption. Its population would rise and fall with the seasons, a natural rhythm dictated by food availability and the presence of its enemies. The moth's expansion from its native continent is a story of accidental partnership with humans. It did not fly across the vast Pacific Ocean on its own delicate wings. Instead, it became an unwitting beneficiary of global trade. As goods, particularly agricultural products like fresh fruit and ornamental plants, began to be shipped from Australia to other parts of the world, the moth came along for the ride. Its eggs, small and easily missed, could be laid on the surface of an apple. Its larvae could be nestled deep within plant leaves, hidden from inspection. In this way, it crossed oceans and continents, a silent and invisible immigrant. The first stop on its world tour was its close neighbor, New Zealand. It was first recorded there in the late 1800s, likely arriving on shipments from Australia. The new environment was highly suitable, with a similar climate and abundant food plants. From New Zealand, its journey continued. It was later found in the United Kingdom and Ireland, having crossed halfway around the world. It also established itself in Hawaii, another island ecosystem far from its origins. Each new location was a testament to the moth's resilience and the ever-increasing speed of international commerce. The moth's arrival in North America marked a significant new chapter in its story. In 2007, it was discovered in California, causing immediate concern among agricultural authorities. Its presence on the mainland of a new continent opened up vast new territories for it to colonize. Genetic analysis confirmed that the Californian population was closely related to those in Australia, leaving no doubt about its origin. The discovery highlighted how, even with modern quarantine procedures, tiny organisms can slip through the net, carried by the relentless tide of global trade and travel. When the light brown apple moth arrives in a new land, it often finds a paradise. The natural enemies that controlled its numbers back in Australia, the specific wasps, flies, and predators that evolved to hunt it, are not present. This absence of natural control allows the moth's population to grow rapidly, far beyond what would be possible in its native habitat. It is like an army arriving without any opposition. The moth can then multiply and spread, its numbers unchecked by the forces of nature that once kept it in balance. This population explosion is the root of the problems it causes. The primary impact of the apple moth is on agriculture and horticulture. The caterpillars have a very broad diet, which is why they are so successful. They are known to feed on more than 250 different plant species, including a wide variety of important crops. They damage fruits like apples, pears, and grapes, making them unfit for sale. They also attack vegetables, ornamental flowers, and even forest trees like pine and fir. The caterpillars chew on leaves, flowers, and the surface of fruits, and their leaf-rolling habit can stunt the growth of young plants. This damage can lead to significant economic losses for farmers and nursery owners. In places like California, the arrival of the moth led to swift and sometimes controversial responses from authorities. Fearing widespread damage to the state's multi-billion-dollar agricultural industry, officials implemented quarantine zones to restrict the movement of plants and produce from affected areas. They also initiated eradication programs, which included the use of pheromone traps to confuse the moths during mating, and in some cases, the aerial spraying of pesticides. These measures themselves created debate, as citizens worried about the potential health and environmental effects of the pesticides being used over urban and suburban areas. Beyond the direct economic damage, the presence of an invasive species like the apple moth can have wider ecological effects. By feeding on a vast range of native plants, it can compete with native insects for food, potentially disrupting local food webs. Although it is a small creature, the cumulative effect of a massive population can alter the health and composition of plant communities. The efforts to control the moth, particularly the use of broad-spectrum pesticides, can also harm beneficial insects, such as bees and other native pollinators, creating further unintended consequences for the local environment. The story of the light brown apple moth is more than just the tale of one small insect. It is a clear and powerful lesson about the consequences of a globalized world. It teaches us that our planet is more connected than ever before, and that actions in one part of the world can have unforeseen effects in another. The movement of goods across the globe is essential for our economies, but it carries with it an invisible risk. Every shipping container, every airplane cargo hold, every suitcase can be a vessel for life, capable of transporting species to new homes where they can cause immense harm. This tiny traveler highlights the critical importance of biosecurity, the measures we take to protect our ecosystems from foreign threats. Strong quarantine and inspection systems at borders are our first line of defense. They are designed to detect and stop invasive species like the apple moth before they can establish a foothold. Investing in these systems and in the science needed to identify potential threats is not just an expense. It is a crucial investment in protecting our agriculture, our economies, and the health of our natural environments for future generations. It is a proactive step to prevent problems before they begin. Furthermore, the apple moth's journey encourages us to think more deeply about the value of native ecosystems. The reason this moth becomes a pest is that it is removed from the complex web of life that controlled it at home. This reminds us that every species, even one we might consider a pest, has a role to play in its native environment. Healthy, diverse ecosystems have their own checks and balances. By preserving biodiversity and protecting natural habitats around the world, we are also preserving the natural enemies that keep potentially invasive species in check, making the entire global system more resilient. Ultimately, we learn that we are all stewards of the planet. The story of the light brown apple moth is not just for scientists or farmers, it is for everyone. It shows that the natural world is not static. It is constantly changing, and human activity is now the main driver of that change. Understanding how species like the apple moth travel and impact new environments is essential for living responsibly on an interconnected planet. It is a call to be more aware, more careful, and more appreciative of the delicate natural balances that sustain all life on Earth, including our own.